Hi everyone, this lesson is about numerical integration, so the technique of finding areas under curves without needing to perform actual algebraic integrations. So let's take as an example this function which I have graphed here. Now I'm interested in finding the area. Let's say I want the area between a limit of 2 and 5. So this area here. Now there's a couple of ways we can do this. We could split this into 3 equal little steps. We could just approximate the area underneath these curves as 3 small rectangles. Notice that I've taken the height of each rectangle to be the value of the function, the blue line, at the left-hand edge of the rectangle. Now let's start to get a little bit of notation going here. We would say the lower limit here, a, equals 2. We would say the upper limit, b, equals 5. The number of little rectangles that I've drawn is 3. I could choose to draw more if I want, and if I did draw more of them, I'd end up with a more accurate answer, because these little triangular pieces would be smaller, the little leftover bits that I'm not counting. Now what would I need? Well, I'd calculate the width of each rectangle as the upper limit, take the lower limit, divide by the number of rectangles. In this case, that's very straightforward. 5, take 2, divide by 3. I've chosen quite straightforward numbers for myself. So I have a width of each rectangle as 1. Clearly you could have seen that by looking at the picture. Now what about the height of each rectangle? Well, the height of the rectangles, a little bit of extra notation here, I suppose. Let's just move that little bit of writing down a bit out of the way. Bit of extra notation. This first x coordinate is designated x0. The next x coordinate along, x1. Now that would be x0 plus the width of the rectangle. This one will be x2 and so on. This one will be x3. I might actually designate it as xn, because in general, in my case, n equals 3, it's x3. But if I had used 10 rectangles, it would be x10. Always start with 0 though. Always start with 0 on the extreme left-hand side, which is the same as the value a, the lower limit for the integration. Okay, now I would calculate the value of the function at x0 to get the height of this first rectangle here. I would calculate the value of the function with substituting x1 to get the height of this rectangle. We call these left-hand rectangles because we're using the left-hand limit, or lower left-hand side. And again, I'd use x2 to calculate the height of the third rectangle. So let's do this area. The area underneath this graph, well, it would be w, the width of the base of the rectangle, multiplied by the function substituting x0. That would give me the height of the first one. I would have w times the function evaluated at the value of x1 plus w times the function evaluated at x2. Now it might have been more straightforward if I factored the w to the front of this formula, because it was a common factor. And that's usually the way we would write this. Note that for left-hand rectangles, we start with x0 and we finish 1 before the end. Do not calculate the height x3 there, otherwise we'd be going too far. So width was 1. Now what was my function? Well, now this is where I can use my calculator to help me a little bit. So there's my calculator screen. There's the function, so just compare, make sure it's the same one. Now, I'm not sure if you know, but when we type functions into the graphing app, we can come across here to the table app, and it automatically copies the same thing across. I'll just draw up a table of values. So there's the x values, 1, 2, 3, 4. Hopefully 5 is there, good. We don't need 5, we only need 2, 3 and 4. And here are the y values. Don't worry about the y dash, that's just So the numbers I need for the heights of these things can be calculated on the machine. I could substitute the value of 2 into this formula. 2 squared is 4, 4 times 0.3 is 1.2, another 2 times 2 is 4, so it adds up to 5.2. But so much easier just to copy them down. So let's do that. Now, I'll just read from my calculator screen. The height when x equaled 2 was 5.2. When x equaled 3, the y value was 8.7. When x equaled 4, the y value was 12.8. And if we add those up, what are we going to get? 8 and 2, that's 1.5, plus another 2, that's 1.7, carry the 1. 1 and 2 are 3, plus 8 is 11, and 5 is 16, carry the 1. So I think that's 26.7 square units. It's approximate because I've only calculated the shaded rectangles there. That's a left-hand rectangle sum. And I think that's enough for this short video. Thanks for watching.